Okay. We don't really need this. I can do something like this. It's fine. And honestly, I don't even need my name. Okay. So it looks like we're streaming okay. I hope everyone had a great weekend. So um, right now, let's just use the chat. If you need to get my attention, just type it into the chat, just so we can kind of keep it all moving. Um, okay, let's do this. Mm-hmm. Oh, I see. I didn't really want those to show, but that's okay. Okay. And I meant to call this name before. I'm not going to worry about the rest of that. Okay. So it's Nicholas Ridgel, Dylan Land, or Jordan Ayub. Those are the only names I didn't get on my roster for today. Everybody else, if I didn't call your name, that means you got attendance credit for today. Yeah, yeah. That's pretty much how that goes. And I think you guys can check it on your end too. That whole thing. Let me see. There shouldn't be. I don't have anybody waiting on my end. I let everybody in. They might still be connecting or whatever, but most people should be in. Yeah, Mr. Robinson. Yeah, I got you. So I took attendance as I let people into the room. I let everybody in one by one, so that way we can't just get rated again. I mean, we probably still could. I'm sure there's always a way, but now I have to just rev things up a bit. That's all. You always got to match the energy. So as I let people in one by one, this is why it's important to kind of like have your name showing on some level. So that I just took attendance as I let people in. Let me see the time. I think I'm gonna let it sit for a couple of more minutes. I'm gonna lock it out. I intend to lock it out. Hey Siri, set a timer for 2 minutes.
Okay, your timer is set for 2 minutes.
So I'm gonna lock the meeting at the 15-minute mark. I can't think of anything else. Oh, so we're gonna incorporate Alex for our lab. We're gonna use Alex for our lab grade. That's gonna serve as our lab. If you were a new freshman this summer, then you should already have an Alex account. You can actually go ahead and get started. Um, if you don't have an Alex account, just let me know, and we'll be sure to get you set up. Okay, let's see. Okay, let me go ahead and log that. Let me go here, like this, like that. Mm-hmm. Are you not gonna work? There we go. And then that is okay. Yeah, they might be in the wrong room. Just tell them to check their email, and they should have a link, right? And so we're gonna go back to the way we were doing it originally, with some modification, where I send out a link every day. I mean, we were comfortable. It is what it is. So again, we're gonna incorporate Alex into our class. So Alex is gonna be used for our lab, and what Alex does, it'll give you like a set of questions, and then based on how you respond and how you do, it'll create another set of questions that's like, okay, if you're showing like deficiency in any kind of concept or skill, it'll give you questions related to that. So like if you're deficient in factoring, it'll give you factoring questions. If you're deficient in something that you're really already supposed to have before you get into this class, it'll target those areas and give you a customized lesson plan for that. So yeah, I took attendance. So if you got into my room, that means I saw your name in my list and I gave you attendance credit. So if you're in the room, you should have attendance credit. And I want to say that you can check it as well on your end and see that you got credit. So we're going to incorporate Alex for our lab. The lab is going to be 10%. Most students should already have access to Alex. If you don't, again, we can get you set up. Okay, Mr. Land, let me do his attendance first. Let's see if I can get this to work a little bit more smoothly. That's better. hmm See the last one? Nope, he's not the last one. One more outside of Mr. Land. That's okay. Gonna let him in, but boom. Awesome sauce. Okay. What is it? But yeah, if you need help registering or getting an account, just let me know and we'll get you set up, and we'll do that. Okay. Alex. So Alex is it's an online learning tool, right? So if you were like if you are a new freshman this past summer, you already have an Alex account because I think they set with every freshman and got them set up. If you don't have an Alex account, we'll get you set up. So just let me know and we'll get you in there. And so basically, we're going to be expected to do like 25 lessons every week, right? And so Dr. Lamar is overseeing that, and she's going to grade it herself, and she's just going to send me a report. So I'm going to be looking for the report from her. Again, if you don't have an Alex account, then we'll just let me know, and we'll get you in there. Cool beans, everybody's here. That's awesome sauce. So yeah, we're gonna go back. That is different. So Pearson is different from Alex. Let me update this thing. Okay. So we're going to be doing both. I know it is what it is. You know, we got to do what we got to do. That's kind of how that goes. Okay. So yeah. Alex is the lab. It's just a lab that's designed to fill in any gaps or holes that got us into this course with the lab. Because when we took our placement exam, we placed into this, right? So Alex is there to kind of fill in any gaps because I'm clearly gonna miss. I'm not gonna be able to fill it in. I feel like a system like Alex will be more proficient at filling in any deficiencies, any area that we might be deficient in. And so all you do is like once you get into Alex, um, we're expected to do 25 lessons a week. If you're going to get an access kit, so you can get that directly from Pearson, right? So hopefully you've had a temporary trial with Pearson. Alex, I want to say that's included. You shouldn't have to purchase that one. But Pearson is how we're going to do our homework, quizzes, and exams, all right? Oh yeah, no, it's okay. You got full attendance credit. No need to worry about that. Okay, I'm going to kind of ignore this for a moment. Yeah, so we're expected to do 25 lessons in Alex a week. So the idea is that what we're going to do, um, so like for instance, this week this is the top of week 5. So for this week, we're going to be focusing on section 1.4. If we finish 1.4 early, then for the any sessions that we have remaining, we can all be working on our Alex accounts. Um, uh, we still doing Pearson. Everything for Pearson should be the same, all right? Pearson is just like everybody's still kind of like purchasing an access code, and so that saga remains the way it is. All right, go ahead, Mr. Lamb. Oh, you had to type it. You had to type it into the chat. Let me. Yeah, just if you can type it into the chat, that's where. I don't think so. For right now, it should not cost any money to get into Alex. Right? It should be included. So don't spend any money on Alex right now. I gotta kind of confirm that one. But we should be purchasing access to Pearson. The late penalty for Alex is not the same. Is so Dr. Lamar is gonna grade it. Whatever she has in her report, that's what I'm gonna use for our lab grades. Right? Yeah, I'm okay with that for right now. Yeah. So for Pearson, the late percent the highest you can get is a 90 for Pearson. Yeah, I'm okay with that. So that means honestly, if you want an A and everything, even exams, you can still get an A. Unlimited attempts, it's going to be set to take your highest score. Okay, so let's kind of hold off on the questions. I mean, you can still keep typing it into the chat, but I'm going to take some time to go ahead and get into today's lecture. This looks good, and let's switch this view, this one, and we're going to go ahead and hop into the lecture for today. No. We just started Alex like today, right? So I won't get a report, I think, until maybe next week sometime, end of next week, something like that. Okay. So yeah. So Alex, we just started this week. Like today is the first day we're starting, but you pretty much do that on your own. And again, if we finish this lecture early within the week, any in person time that we have remaining, you can be actually be working on your Alex during that time. Honestly, if you wanted to work on it now, you can, but then that means you're going to be distracted, right? So you have to kind of decide how you're going to work that. So today we're going to start with section 1.4, a library of functions. And some objectives here. We want to define linear functions, discuss important properties of functions, graph the square root and cube root functions, evaluate and graph piecewise functions, graph basic functions, and find the average rate of change of a function, right? So we're going to open up with a few linear functions. We're going to let m and b be real numbers. Then the function f of x equals mx plus b is called a linear function. Let's go like this. I hope everyone had a great weekend as well, or productive, or you was able to just kind of have some time to yourself to do what you needed to do. If m is 0, if our slope is 0, then the function f of x equals mx plus b becomes just this guy, y equals some number, or f of x equals b. This is called a constant function. This is our first basic function. The graph of y equals some number is just going to be a horizontal line through whatever that number is. If the slope is 1 and the y-intercept is 0, then the next function is called the identity function. It's like y equals x. Y equals x, right? So the first one is called the constant function. That's y equals some number. That's going to be a flat horizontal line through y equals whatever that number. The second basic function is called identity function. That's y equals x, right? So it's going to be a diagonal line. So the graph of a linear function is a non-vertical line with a slope m and a y-intercept b. Right? So in this first one, notice as we trace it left to right, as we trace this first one left to right, it goes up. Right? It has a positive slope. Again, as we trace it left to right, it goes up. Up. Right? The second one has, I guess we can, did my timer go off? It surely did not, but that's okay. Maybe it did and I just wasn't conscious of it. Let me, this one. Come on. There it is. Security, we're going to go ahead and lock it up. I'm sure there's a shortcut, but that's okay. Okay, so I think we were only missing one. It wasn't too bad. So again, if a line has a negative slope, as we trace it left to right, it's going to go down. All right, negative slope, it goes down. Say the slope is 0. That's going to be y equals some number. So that's going to be a flat horizontal line through y equals that whatever that number is. Right? Again, this is so this is called the constant function. That's y equals a number. This is called identity function. Y equals x. This is y equals x. Let me just clear this page. That's fine. So we're asked to write a linear function g for which g of 1 equals 4 and g of negative 3 equals 2. Okay. So this is saying, when x is 1, y is 4. When x is negative 3, y is negative 2. So we have these two sets of ordered pairs, right? I usually like to go ahead and automatically label them x1, y1, x2, y2. Okay. So then basically we're finding the equation of the line through these 2 points. Okay. So let's start off by finding the slope between 2 points. The slope formula is going to be y2 minus y1 over x2 minus x1. Okay, so our y2, we're going to say negative 2 minus 4 over negative 3 minus 1. That's going to be negative 6 over negative 4, which becomes a positive 3 by 2. Okay, so we have our slope. And then I'm a fan of slope-intercept formula. So if we have the y equals mx plus b, we can choose either point. I think in my first class, I chose the first point. This time I'm going to choose the second point and see if the same thing happens. So we're going to say negative 2 equals our slope, which is 3 by 2, times x, which is negative 3, plus b. So the only thing we don't know is b. So then ultimately b is going to be equal to, that's going to be what, 9 by 2? So it's going to be negative 2 plus 9 by 2. That's going to be negative 4 by 2 plus 9 by 2 to give us 5 by 2. So we did get the same y-intercept. Okay, so we got our b. And we got our m. So then the equation of the line can be y equals 3 by 2x plus 5 by 2. And we can check this like, so I'm going to check this in my graphing calculator. I'm going to check it here. All right, let's go ahead and reset everything. So if I go to my y equals, I'm going to type in that 3 by 2x plus 5 by 2. I'm going to quit. So on the calculator, you see this button clear. To the left of that, it says variables, VARS. I'm going to click on that and then go to the right to y variables. I'm going to click on number 1 for function and number 1 for y1. So I'm just all I'm doing is calling on that function I just typed in. And so when x is 1, the y value should be 4. And when x is negative 3, the y value should be negative 2. So for the y-intercept, after we found the slope, okay, the y-intercept, so we found the slope here, right? We got this 3 by 2. So then we use the slope-intercept form, y equals mx plus b. I think the book is going to do point slope. So the other equation that the book is using that we didn't use here was the point slope, which is y minus y1 equals m times x minus x1. This one works, but I feel like that one's more challenging than the blue. I feel like the purple is more challenging than the blue. So I'm a fan of the blue. It's all about keeping it simple. So then if I started with the slope-intercept form, let me create a little bit of space here. Oh, just missed. Okay, what if I move you here? Put you back. Now we can easily shrink you down. Okay, that's better. Okay. So if we start with the y equals mx plus b. I chose one of the points. I could have chosen this one or this one. I just chose the second one. So when y is negative 2, our slope was 3 halves, and our x was negative 3. Negative 2, 3 halves, and negative 3. The only thing we didn't know was b. All right? So the multiply fractions is the top times the top and the bottom times the bottom. This became a negative 9 halves. Right? This became a negative 9 halves. So then I added 9 halves to both sides. That's where this came from. then just adding fractions. You can use your calculator. You don't have to do all this by hand. You can use your calculator to crunch some of these, right? And we tested this formula and it worked. It worked in both of them. Yep, no worries. Thank you for the question. Let's move forward. Okay, I think we're done with the calculator. So we confirmed that our function works. Our function is functional, right? And so this original slide, because of the way I created it today, it was missing out on a lot of the symbols. So I went and manually filled in the proper symbols, and you can see where it matches up with what we have. Okay. A similar thing here. I think this one was missing a lot of symbols because I printed it from my iPad instead of the laptop. So the functions didn't, the symbols, all the symbols didn't populate properly. So I'd have to go back and do it on the computer. But I went on and filled in what I knew was supposed to be there. Okay. So then we can talk about what do we mean by a function is to be increasing, decreasing, and constant functions, right? So we're going to say let f be a function and let x sub 1 and x sub 2 be any two numbers in an open interval AB containing the domain of f. Then the symbols a and b may represent real numbers, negative infinity or positive infinity. Then the following is the case. We said that the function is increasing on an open interval AB if whenever x1 is less than x2, this implies that f of x1 is less than f of x2, right? So the simple explanation is in a graphical sense, as we trace the graph left to right, it goes up. Right? As we trace the graph left to right, it's always going up. That's what we mean by a function is increasing. A function is decreasing, the simple explanation is as we trace it left to right, it goes down. So whenever a function is decreasing on an open interval AB, whenever x1 is less than x2, that implies that f of x1 is larger than f of x2. All right, so again, the simple explanation is as we trace the graph left to right, it goes down. Okay. And then, let me see, this one, we said that a function is constant on an open interval AB if whenever x1 is less than x2, this implies f of x1 is equal to f of x2, right? So the simple explanation is, as we trace it left to right, the graph stays flat or constant. As we trace it left to right, the graph stays flat or constant. Man, that's interesting. Anyway. Let me clear this slide. I know we see the answer there, but that's okay. So it says, from the graph of G, find the intervals over which G is increasing, decreasing, or constant, right? So notice initially, as we trace it left to right, it's going up, right? So over what part of the domain is this increasing? What's the far left? How far left does the graph go? What's the far left? Yeah, the far left is negative infinity, right? So we're saying that it's increasing from the far left is negative infinity up until, what's the x value here? So it's increasing from negative infinity up until here. What's this x value? This x value is negative 2, right? So we say it's increasing from negative infinity to negative 2. So whenever we're doing our discussion of increasing, decreasing, or constant, it seems like this text does what I agree with. We're just always going to use parentheses for this discussion. Increasing, decreasing, or constant, we're just always going to use parentheses. So from negative infinity to negative 2, the graph is going up. And then from negative 2 until, what is this? What's this x value? 3. So from negative 2 till 3, it's staying flat or constant. So we say that it's constant. I don't know why I keep doing that. We said it's constant from negative 2 to 3, right? This is based on the x-axis. No. So for this discussion of increasing, decreasing, and constant, we just use parentheses across the board for this. Because if we did a square bracket, then if we did a square bracket, then we, like I said, we were at -2 on that money. Then we won't always have that contrast, right? We got to have the contrast. But yeah, it's no worries. Because this is actually, it's one of those topics. I don't. It's okay. It's actually a debate. Like um, some books don't. Some books do use brackets, but I'm of the mindset of this book where it's all parentheses for this discussion. And then on the right side of 3, the function is always decreasing, right? It just keeps going down. So we're saying from 3 to infinity, the function is decreasing. Okay, not too terribly bad. Let me see. Okay, so we stopped about the same. I don't want to go too much further. So from the graph of G, find the intervals over which it's an increasing, decreasing, and constant. And I think we got the same thing as earlier. Okay, did you guys want to ask any questions from the homework? So now is actually a good time. I only want to keep it for like no more than like 5 minutes. Now is a good time to go ahead and see. Can you log into Alex? Let me go ahead and load a copy of this for you guys. So let me share, send it to Box. I must not have loaded it from the last class. Is this one? This one? I think it's this one. Okay. Okay. I mean, yeah, honestly, I didn't really want to take you much further beyond that. I think it's alex.com. So Alex is spelled, let's see, Alex, how's Alex spelled? Is it CK? EKS? Something like that. It looks like this. Let me go to the site and pull it up. Yeah, Alex. ALEKS.com. You again, if you are a new freshman, you should be registered. If you don't have an account, just give me like a day or two. I gotta contact my colleague to see how do we get you guys in there, because there's a whole thing to get you guys in there. But no, we can get you an account. And this is our lab grade, right? We're gonna use this for our lab grade. Okay. All right, guys. I didn't really want to keep you much longer than that, honestly. Since we got 10 minutes, I'm kind of okay with that. And we did the same thing as the earlier class. Let me kind of go ahead and unmute, allow you guys to unmute yourself. Yeah. So, if you have a question, now's a good time to ask it. Otherwise, if there aren't any questions, I'll let you go, and we'll meet back tomorrow at like 5:15. Okay. All right, guys. Thanks for being awesome. Take care.
Thank you.
Yep. Okay, cool. I'll let it be. So.